Alright, so now welcome to my YouTube channel. This is the continuation of the first order linear differential equation that we are talking about. Now we're going to look at the solution, how to solve them, okay? We have already established the standard one. But when it comes to the solution, we have two ways of doing it, two methods. We can use the undetermined coefficients. We can use this one, the coefficients, then method. You can also use the integrating factors method to do it. And you are familiar with the integrating factors. Yeah, that one you are familiar with it. Then the undetermined coefficients method. Or some people also call method of undetermined coefficients. They are the same thing. Method of undetermined coefficient. Okay, so now looking at these two, this is what we are going to use. But for now, I'm going to consider the method of undetermined coefficient or undetermined coefficient method. So let's consider that one first. Now, we established that dy dx plus p of x y is equals to k of x. Is that okay? Now, when it comes to the method of undetermined coefficients, what happens is that first, you send the whole equation to homogeneous first. So when we are doing that, meaning that I'm going to have dy dx plus p of xy equals what? 0. So that's when k of x is equals to 0. When I do that, I can have dy dx equals negative p of x multiplied by what? Y. When I do this becomes a separable something. Becomes separable because I can bring the y here and I'll bring the dx here. So that I'll have dy over y equals negative p of x dx. Something like this. So now dy over y equals negative p of x dx. So we take the integral on both sides. And this one is going to give us ln y plus negative integral of p of x dx plus ln c. So I can bring the ln c to this place, right? So I'll have ln y minus ln c plus negative integral of p of x dx. Now these two can be written as this, because negative integral of p of x dx. I hope you are okay with this side. Now at this point, I want to take off the lane, so I'll just bring e here and bring e here, so that this e will cancel this, and I'll have y equals c e to the power negative integral of p of x dx. You know, here if I do cross multiplication, this c will come and multiply this. That's what I've written there. Now, this one that I have here is the solution for the what? The homogeneous. So let's attach h to this. Okay. Now that we have the solution for the homogeneous, we want to, or you can call it general solution then, by the solution for the homogeneous. Now I want to find for the particular solution. Okay, so this is what we are going to do. Okay, so when we get to this point, the idea is that the constant here, write it as a function of the other. So that the function of x, so we have, and represent that one by a particular solution. That will be y of p, and we have c of x e to the power negative p of x dx. So the only thing that I've done here is that this constant, I've changed it to c of x. So you always let the constant be in terms of a function of x. Now let's differentiate this one. If we differentiate this, we are going to have dy dx. Forget about the subscript p, okay? No problem. Equals to, and there is a product through c of x and p of x. So let's hold this. Okay, let's hold this and differentiate it. This will give us c prime of x e negative integral of p of x dx. Now, let's hold this and differentiate this. If we differentiate this one, because of the negative, it will give you negative. And if you differentiate integration, you get differentiation is reverse of the other. So this is what we are going to have. This one, we're going to have, so going to be plus, but because of the minuses, we are going to have minus c of x multiplied by p of x e integral of p of x dx. Don't be worried about the proving, okay? Because sometimes they will not ask you to prove. If they ask you to prove, you have to be able to. What I've done here is that when I hold this one, if you are differentiating this exponential function, so you differentiate the top one, that will give you p of x, okay? Times whatever that is here. Then multiply by the whole function again. Times ln of the base, that's in each one, so that's why I don't normally bring it. So that's what we have now. After getting this, you go back to this, which is dy dx plus p of x y equals k of x, okay? So this is what we are going to do. This y here is for this one, y of p, okay? And so what I'm going to do is that wherever I see y, I'm going to substitute all this one there. And wherever I see dy dx, I'm going to also substitute this one here. Or put the whole of this one here. That's what I'm going to do. It's not a small job. So first thing, dy dx is here. So you're going to put that one there. So we have c prime of x e to the power negative p of x dx for this side minus, so let me bring it here, c of x p of x e negative integral of p of x dx. I'm done with this side, so I'm coming to this place. So plus p of x. So you see I'm done with here, dy dx. That's for the whole of this. Then I'll come to this place. So p of x multiplied by y, and I'm saying that this is my y, which is c of x e exponent negative p of x dx. Then I'm done with this one, equals to k of x. We know k of x, we don't know, so let's maintain that one. For the k of x, we don't know. Okay. So now, let's see if you can do translation. P of x, this is positive p of s, t of x. And this one is negative c of x, p of x, and this, they are the same. So this one, the whole of this, and the whole of this will go. Leaving c prime of x e negative integral of p of x dx is equals to k of x. So at this point, I can divide both sides by this one. So I have c prime of x equals to k of x e integral of p of x dx. You know that if I divide through by the whole of this one, because of this negative, when it comes to become positive, so that's why I've just written it straight away. Is that okay? So this is what we have. So at this particular point, I want C prime. So I want C, not C prime. Okay, so I have to integrate both sides. So as I'm doing, don't forget of the YP and the Y. Okay, the YP and the Y. So now, C prime of X is equals to K of X E integral of P of X dx. Is that okay? So now at this point, I take the integral on both sides. Okay, so now that we have this, if you integrate this one, to be like a wall, so we leave it like that. So let's leave it. That will be K of X E integral of P of X dx or dx like this. Is that okay? So this is what we have. Remember, don't forget that we have y of h, which we had C E exponent negative P of X dx. And we also have y of P, which is C of X E negative P of X dx. Now this C of X is what we just worked for. So the whole of this here, C of X, is going to be replaced by the whole of this one. Okay. So when I do that, let me write it down here. So y of P is equals to C of X is what we have here, integral of K of X e to the power negative integral of P of X dx or dx. And the whole of this one is multiplying by this, which is e negative integral of P of X dx. Guys, this is the formula for y of P, the particular solution. And the formula for y of h is this one. I think it's very simple. Now when you finish, you want to find for this general solution of this is given as y of h plus y of p. So meaning of it is that you take all of this plus the whole of this, and that will give you the general solution of the first linear order. Y of h plus y of p. And you see how we got this one. So this is just a formula. This is just a formula. So let's look at an example. I know some of you are even confused, but don't be confused. Follow the team keenly, you understand what you are doing. Okay guys, so now let's look at the example. We are going to use the method of undetermined coefficient to do this. We have to find the general solution of this using the method of undetermined coefficient. You realize that we have not gotten to anywhere yet, but we are seeing a lot of concepts, different ones. So even if the question is there, you wouldn't even know the kind of this thing to use. So that's why you have to follow keenly. Yes, and practice more. So find the general solution of the equation. So first thing to do, dx minus 2y over x equals x over 2. This is the standard form, meaning that my p of x is equals to negative 2 over x. Then my p of x is equals to x over 2. So you see, don't write in the standard form. You might make a mistake here. Okay, very good. For this, you can just go and quote the formulas and do the substitution. You are good to go. Okay, but I normally don't write deal with the formula, because the way the formula is too lengthy, it will be very, very difficult for you to use it, to memorize it here. So you look at the procedure I'm going to use. When I was proving the formula, I said that when they give it to anyone to solve, first solve it homogeneously first, meaning that put the q of x to be 0. So when you do that, when I put this side to be 0, meaning that I'm going to have dy dx minus 2y over x equals 0. This is what I'm going to have. So that I'll have dy dx equals 2y over x. This is when I was even solving or proving the formula, I did something like this. So that's what I'm saying, you don't need to choose the formula. Now from here, we can have dy over y equals dx. 2 over x dx. Because I can bring this y here and then the x there. So that it becomes separable. Once it's separable, you can integrate it. If I integrate this, I have ln y equals 2 ln x plus ln c, which will give us ln y minus ln c equals ln x squared. Is that okay? The laws of logarithm, these two can come to here. That's and this one will give us ln y over c equals to ln x squared. Laws of logarithm. When you are subtracting, you divide. So we take e on both sides. When I do that, I'm going to have e to the power ln y over c equals e to the power ln x squared. And this will give us y over c equals to x squared. So that our y equals c x squared. This is the homogeneous, so we attach subscript h to it. Now we said that if you want to get the y of p, that one, this c should be written in terms of what? A function of x. Okay. So this one I will get. Then after that, we differentiate this. Okay. So let's look at how we differentiate this. That will be dy dx. And I told that when you are don't bring the p, is equals to c prime of x squared plus, I hold it now, differentiate this because it's multiplication and it's product through. That's what I'm doing. I hold this and I hold this when I differentiate, I'll get c prime of x times the x squared. This time I'm going to hold this and I'll differentiate, that will give me 2x. So 2x times c of x. Something like this. Okay. When you finish this, just like when I was proving the formula, what I did, you just take the whole of this one. Okay. The whole of dy dx and the whole of yp, then you go back to the question given and you do the substitution there. So let's do it here and you see. So this one was the question given. So dy dx is c prime of x times x squared plus 2x times cx. So we have c prime of x times x squared plus 2x times c of x. So this one we have plus y of p is c of x times x squared. C of x times what? X squared. This is what we have. And remember, okay, this one is not plus. After the dy dx is equals to. So now this side I'm going to have 2. Now the whole of this y is that y of p here, which is c of x times x squared. And the whole of this is divided by the limit. Cx, it's just x here. And if you look at this one and this, they will be the same. So this one will cancel this. So that we'll be having c prime of x multiplied by x squared equals x over 2. Please, the calculation I've done here. This x and this one will cancel, leaving 2x times cx, c of x, which is the same as 2x times c of x. And this one is, so when I bring the h to this place, become negative, then I'll do the cancellation, leaving this one. So now that we have this, we divide both sides by x squared. So when you do that, I have c prime of x, because if I divide, one of them will cancel this, so I'll have x over 2. I'll have 1 over 2x, because one of the x will cancel, leaving 1 over there, 1 of the x here. So I'll take integral on both sides, and this will give us c of x equals half ln x. Remember, if I bring the half out, it's leave it 1 over x. So that will be a function derivative. Plus, sorry, here we don't bring constant again. So we have this as our c of x. When I was proving the formula, I told you that after any wages, you go to the y of p to substitute it back there. But remember that if I want to get my general solution is y of h plus y of p. Is that okay? So first thing, you have to be able to know where our y of h is equals to cx squared. Then our y of p is equals to c of x, then x squared, right? So this is what we have. So our final answer for this is going to be y of h, which is cx squared, plus c of x. C of x, we have half ln x squared multiplying by x squared. So I can write this one well, c of x squared plus this multiplied by that will give us half, so x squared over 2 ln x squared. So this becomes the final answer to the question. This becomes the final answer to the question. So you see, you don't need to go and quote the whole formula down. You can just follow the procedure how I put the formula to get your answer. First, send it towards the homogeneous, then you proceed from there, then you continue from there. Thank you very much. Let's look at a second example. Okay, so now let's look at example number 2. Find the general solution of the equation and a particular solution that satisfies x of 0 equals 1. So this is the equation. Remember, x here becomes the dependent, not independent in this case, and the t becomes the independent. So this one can be written as dx dt, okay? And this one has to be brought here so that it becomes the standard form. So this is what we have. As I said, first thing we have to deal away with this one, let it go to 0, so that we are going to have dx dt. Then let me maintain it there. So if I send it back, I'll still have positive. So this is what I have. So at this point, it's separable, right? So I can separate it so that I can have dx over x equals to sine t dt. So we integrate both sides here. If I integrate this, I'll get ln x. I have ln x equals, if you integrate sine t, you get negative cos t. So this one is going to give you negative cos t. And then plus ln c. So this is going to give us ln x minus ln c equals negative cos t. This will give us ln x over c plus negative cos t. So that my x will be equals to c e exponent negative cos t. At this point, I know that you are now strong in this. You just take e on both sides. You take e on both sides, then this will go and the e will carry this. And do cross multiplication, the c will multiply the e. That's what I have here. So you can see that this becomes our h. So x of p now becomes c of t, e negative cos t. So you write this one in terms of the function of the independent variable, just like what we did for the other one. So this and that's what I want. But before I can proceed, we need to differentiate this one with respect to c. And that will give us c prime of t, e negative cos t. Okay, so plus. Now let me hold this one, which is c of t. Now differentiate this. This one, if we differentiate this one, this will give us cos t will give us negative sign t, so negative will give us positive. So that gives positive sin t e to the power negative cos t. So that's how, when you differentiate this, you are going to get. So now at this point that we are having this, we are now going to do the substitution. So wherever I see dx dt, I'll put the whole of this one there. Wherever I see x is the whole of this one. Is that okay? So let's start with that. So I'm starting with this. Dx dt is going to be c prime of t multiplied by e to the power negative cos t plus c of t multiplied by sin t e to the power negative cos t is equals to x. Where's our x? This is our x. C of t e to the power negative cos t plus, this is 2t e to the power negative cos t. So this is what we have. So let's see. This is ct sin t. Have I left something out there? C prime of t e to the power negative cos t plus ct sin t. That is what is here. Then here will be, this is x. The x is c of t e to the power negative t multiplied by sin t. Sorry. Sin t plus this. So you realize that this one and this are the same. So if I send this one to the other side, it will cancel this. So this one will go with this one. So when the cancellations happen, then we have c prime of t e to the power negative cos t equals 2t e negative cos t. So this is what we are going to have. So let's divide both sides by this. That will give us c prime of t equals, so when I divide both sides by this, will cancel this, leaving 2t. So I take the integral on both sides. So when that one is done, we are going to have t squared. So we are saying that x of t is now going to give us x of h plus x of p. So now let's find out x of t. X of h was what? Okay, so our x of h was c e to the power negative cos t plus c of t, e to the power negative cos t. But now we know our c of t to be t squared, so our final answer becomes c e negative cos t plus t squared e negative cos t. So it means that our x of t, this one can be written as c over e to the power cos t plus this one too can be written as t squared over e to the power cos t. You can have it like this. Now, since the denominators are the same, you can write this one as c plus t squared e to the power cos t. So this becomes the general solution. Okay, so the next point, the question said we should find x at 0 equals 1. So, meaning that t is 0, x is 1. So, x at 0 equals 1. So, when I come to this place, wherever I see t is 0, wherever I see x is 1, so x is 1. So, it's going to be 1 equals c plus 0 squared, all divided by e cos 0. So, 1 is equals to c over cos 0 is 1, so leaving e. So c is equals to e. Therefore, our final answer is now going to be, our c is e, so we are going to have e plus t squared all divided by e cos t. So this is the final answer to that.